Welcome back. Last video I've done, we just started the exam. We worked on activity 1 where we produced a plan table like this. We're going to add a little bit more to this after we've completed activity 2. Bear with us. Let's get to the video. And again, we're going to kick some more ass on this one. And here we go, straight in activity 2. Interpret the client brief and all the other bits and pieces that we're going to talk about on this one here. We try to optimize marks, make sure you're working as efficiently as you can, as well as making sure you don't miss any bits and pieces out. Let's say that there's 4 bullet points there. Fancy missing a couple, you're going to miss points. Now remember, this is for 45 minutes of the time. I think we put 40 to 50 minutes on my time in from the last video. And it's only worth 6 points, okay? So do you need to fill out 5 or 6 pages of this? No, you don't. You're going to have to work as clever as you can to hit the details. Evidence is what they're after. You provide the evidence, you'll be a high marking. As I said before, if you're vague and about business, you're going to have very little marks out of this one. We try and get the best we can, easy numbers. Now, bear in mind, you can do the first 3 bits quite quickly, and you might want to come back to the final bullet point. You are running your show. I'm going to split the screen now into 2 pages. The first 2 paragraphs that you see there, the first one saying is that you only allow to use the research notes you've done for part A, and the information booklet you will be provided with drawings of the top plate, side plate, and the assembly details is towards the back of your thing. It might be separate, but normally at the back of your book as well. At this part here, we really want to try and cover the 2 highlighted bullet points there. Now, to cover something like this, we need to gather the information. So I've made this table like that. I'm going to split the page into 2 pages. The brief for me on the left and the table of details that I've pulled out. Hopefully you can be able to see this. Okay, now if you look on the right side of my page, I created a table which has 3 columns on there. Okay, now where have I got these from? The first one you see there is product requirements, which is my first column here on the right hand side. Then the next side is the opportunities and constraints. Yeah, I've got the wrong way around, but it doesn't matter. I put the constraints somewhat in the middle and opportunity on the outside lane, or the outside column. You can do it like me, where I've created a table, quick table, 3 columns, requirements, constraints, and opportunities. I'm not sure what order they come out first, but this is what you could do here. Please, this is not your answer. Okay, this is where you're dragging the information out. You're interrogating the exam brief that you have here. Okay, so if you look at the first paragraph highlighted there, the work platform is used by maintenance engineers in several automated distribution centers. The engineers put on their tool belt, blah, blah, blah. The switch gear is inside large control panels that are connected to the wall 1.5 meters above the floor. Hence, they need a work platform to get up there. Okay. If you look at the second paragraph that we have here, as you can see, the second paragraph here, the client is aware that the current work platform has a number of issues. We already knew that. They do it where they do such a poor design where you should be able to come up with something decent to come up with it. But the redesign has been triggered by feedback from the engineers and how difficult it is to carry out maintenance tasks when using the work platform. Okay, the feedback is that the work platform is not suitable for several reasons. Okay, so there's nothing come out so far. Now, when you have a look at these bullet points you see here, you'll see the client brief believes that the sourcing issues that the existing work platform are. First bullet point says has a top plate that is too high for some engineers to step onto safely. Okay, so our first requirement is that, as you see on the top right hand side, is in the requirements column, add steps. Right, so you're right there, add steps. The second bullet point that we see here can flex unintentionally when the engineer is using it while completing maintenance tasks. So what have I put on my requirements there? As you see in this, we put more rigid construction. You've got to, it said it flexes too much, so we're going to make a rigid, they require a more rigid construction there. So I'm going to put that little note there. Third bullet point here, can be unstable when the engineer is using it while completing maintenance tasks, especially if the wheel chocks are not positioned. Okay, so unstable, so requirements, they want stability. If the wheel chocks are not positioned properly, we need a type of braking mechanism. Okay, that's what we need there. So Moving on to the fourth bullet point, lacks a method to prevent the engineer stepping or slipping off unintentionally while completing tests, completing maintenance tasks. As you see there, as you come over to my requirements column here, it's a safety thing. So rails, edge, and it says about slipping. Surface not to be slippery. So we need to make sure we cover those bits there. So I pulled those up there. Look at the final bullet point. It's not easy to move from one control panel to another control panel position elsewhere in the distribution thing. So maneuverability is a problem here. So I've put that over on requirements of maneuverability. Now, as you can see here, the client state the design and size of the top plate and side plates must remain the same. So we have a constraint there. So on my constraints column, sizes to remain the same, top plate and side plates. Easy as that. But modifications can be made to them. For example, materials or components can be added. So here on my opportunity bit, extra material and components can be done on there. So I added that. So that's from that paragraph I got there. From this paragraph, the brief says, based on tests, the client provided information in Table 1, which can be used to perform statistical analysis in service work for the work platform. There's nothing there that's no good. That's any good for us. The client had intended life cycle of the work platform to be 8 years. So now that is a requirement. So on my requirements column, I've got life expectancy 8 years. Beautiful stuff. Let's take a look at that bit there. So what can I extract from that? Design alternative solution. So my opportunity here is that it'll be a new design. Bearing in mind the constraints of the top plates and side plates must stay the same. As you can see on my opportunity here, I might want to employ CNC machinery, so use automated processes, laser cutting, CNC brake press for bending the parts up, and robot welding if the opportunity and we get the price down to a good level as well. The second part of this final paragraph, it said you should optimize the designs in terms of safety, performance, sustainability, and other factors. Well, that's a requirement here. That's going in my requirements column here. Optimize. That's what it says there. The word optimize. Safety, performance, sustainability, and other factors. I'll add that there. There we are. Just added that in there for that one there. So you'll be scribbling these down here. Interfaces and using extra low cost components. So wherever I see that opportunity here. So if you look at my opportunity here, design to reduce issues with existing platforms. So that's an opportunity that we're working with. You know, that could go in the first column as well if I wanted to. And if you look at the interfaces using extra low cost components, we're now looking at about off-the-shelf parts, wheels and brakes, fixings, bits and bobs, and in some springs and bits and bobs like that. That's what we're talking about there. Now, I haven't finished there yet. We now have this part here. Okay, now we could repeat exactly what we got here if we wanted to. But if you look at the first bullet point, allow the engineer to step onto and off safely. We're going to add steps onto there to allow that to happen. Be rigid, stable, and safe for the engineer when using it, when completing the tasks. So it's more rigid construction stability. We have a braking mechanism there. We have some rails and an edge, and obviously a safe surface that's non-slippery. Be easy to move from one control panel to another. Now we're looking at maneuverability that we covered there, to be robust enough to last the intended life cycle. Okay, we've got life expectancy 8 years. That's all I can do in that. You need to design a product that will last that bit there and be capable of being manufactured in batches of thousands. So we have manufacturing batches of thousands here. Okay, so how does this look for you? If you've drawn this table, expected that this is going to get you through this, you're going to have to wake up here. This is just a list of all the parts of the brief that you need to work with. Requirements. I've gone through the brief and listed all the requirements that I need to cover. The constraints, I need to find the information through that task of what these are, and obviously the opportunities is what I'm interpreting what are good opportunities for me to produce a better work platform, as we see there. So going back to activity 2, we're back to activity 2. Interpret the client brief and in operational requirements to include. So the first 2 bullet points, we can safely say that we got enough information here to cover this. Okay, now this is what you're going to need for the marks it out. Now if you're willing, you only got 2 or 3 bits in here, but you know what I've pulled out was quite a fair bit, a couple of bits, obviously you're going to be scoring low here, so you need to make sure you have a lot more information here. So looking at activity 2, the first part of this page, you will probably see a table like this. Where you've extracted all the information that you got. Your first paragraph is where you talk about the product requirements. You now have a list of things you can add to that first paragraph to cover product requirements. So far, so good? I hope so. Now, your second bullet point that you see there, opportunities and constraints. Okay. Now, you extracted information and interpreted information from the client brief, and you now have 2 columns of what you can talk about there. Now, without this table, it would have been a lot harder for you to get the information visible for you to work with. So that's why I produced a table. This is only worth 6 points, so don't go mad on this one. Okay, there will be some heavier areas that you want to discuss on a visit, but if you put very little in it, expect very little marks. Okay, we're halfway there, as they say. We now move on to interpreting numerical data. The table supplied, as you see here, is what we need to interpret. It can be easy, it can be hard. So what I've done here is use AI to read out what I put for my notes. Take it away, Jeff. Give him your best shot.
Table 1, Material Testing and Construction Methods. From our data sheet. There are 3 types of material being used. Aluminium, mild steel, and stainless steel. There were 2 types of construction used here. They were welded and bolted together. Testing with shear forces used for welded 450 newtons and for bolted 350 newtons. The mass applied to the top plate for the welded assembly was 90 kilograms and for the bolted assembly was 70 kilograms. There were 6 tests to each assembly to show simulated life cycle to failure measured in years. Which material will you choose? You will need your notes from research task to answer this. Average life cycles. For welded assembly. Material, low carbon steel lasted 3.41 years. Material, aluminum alloy lasted 3.08 years. And finally the stainless steel lasted 4.16 years. Coming to the bolted assembly. The low carbon steel lasted 2.08 years. The aluminum alloy lasted 1.33 years. And finally stainless steel lasted 2.83 years. Our conclusion here is as simple as we can get it. It can be clearly seen that bolted assemblies do not last, on average, as long as any welded assemblies. This had lower shear force and lower mass applied during testing. I would probably avoid this type of assembly. The welded assemblies performed much better, even with higher shear force and mass applied to it. This would be preferred construction of main body. Everything else could be bolted on.
The text used by AI are written here. So pause the video, take a look at both of these images to see what I put down for the interpretation of data provided by BTEC themselves. Hope this bit makes it all clearer. Just pause it here, take a look at the notes. This is what you expected to put down for your exam. If you get majority of this, you will add decent points to your section here. Now remember, it's only worth 6 points, so just be wary how much time you spend on here as well. 40 to 50 minutes is maximum. Now we haven't even done the last bit yet, which we're going to come to now. Our final bullet point here, key health and safety, regulatory and sustainability factors. Now you're going to have to draw this information from your research notes. I would put these down as bullet point statements here. If you've got stuff that's decent, that is relevant for your the product, then you've got to stick it down. Don't be generic. Oh, health and safety at work Act 1974, blah blah blah. It's not. That's the generic answer. You need to be specific. Okay. So obviously, someone's going to lift this thing. Okay. So in manufacture, so there'll be some manual handling. It's going to be painted, so there needs to be health and safety regulations on that. Now, for the user, it's a work platform, so they need to be trained working from height. Also, when manoeuvring it, again, it has to be locked off and all that business. You need to be trained how to use the equipment, as they call it. You know, if you go out a ladder and you've not been trained, you fall off, it's your fault. If you have been trained, if you've done everything to the T that you've been trained for, it's a keeper. You are, as they say, done everything as physically possible to the procedure for using ladders and so on like that. So here you're going to have to be solely relying on the notes that you've taken for your research task. Okay. Now, if you haven't done this, then you're going to be out of luck. Now, really, you want to be consistent across the whole board. It is only 6 points. Keep it as succinct as you can, to the point, and make sure you don't waffle, because when you're waffling, you're eating up your time. 40 to 50 minutes is all you got on this. This is where I'll hand you back to myself so you see me face to face. Here we are again at the end of, well, nearly at the end of the video. So that last bullet point, key health and safety, regulatory and sustainability factors. Keep these as simple bullet point statements, as I said in the video. These will solely come from your research notes. Again, we don't know what the product is. Well, we do know what the product is, but I can't discuss it on the video. Have you done something for that? And it's just a matter of, if you copy and pasted the right stuff, you should be able to put something on this. And it has to be relevant for the product. So whatever the product is, needs to be relevant for that. Now, don't go in, oh, health and safety at work act, blah blah blah. So that's the umbrella act. For all the other bits go underneath it. That's included on it. So you need to be specific for the actual things for your product, that product that you're working on. Okay. Now, the next video is on activity 3. Ciao for now. See you in the next video, which should be out not tomorrow, night after. So every other night you should get one out.